Welcome to your own channel of Right Funda.
Here is an interesting problem from chapter magnetics, the charged particle moving in a magnetic field. Let's read the question. The XY plane shown in the figure contains uniform magnetic field B is equal to B k cap, that is coming out of the screen, for y greater than 0. A particle having charge small q and mass small m travels along y-axis. At origin of the coordinate system, velocity of the particle is v0 and it enters the region containing magnetic field. Assume that particle is subjected to a frictional force F is equal to minus alpha v. Yes, very different type of friction force, where friction force is proportional to the speed of the particle, the resistive force, opposite to directed. That is, frictional force is proportional to velocity. Assume frictional force is large enough so that particle remain inside the region at y greater than 0 at all the time. The only force acting on the particle are frictional force and the magnetic force. Particle will remain in the xy plane as no magnetic force acts along the z-axis. Find the x coordinate where the particle comes to rest. So what question is given is that the particle starts moving like this with a velocity v0 like this initially, but as the magnetic field is coming out of the screen there, so it experiences force and it starts moving in a curved path, eventually move a spiral path, and its speed is decreasing and finally come to rest. Where it will come to rest? So where the point will coming, suppose x0 comma y0, you need to calculate this x0 coordinate where it will be coming to rest. So now you have understood the question. You start solving the problem, give a fair attempt. You may pause the video and after solving you can again resume the video and check your way of problem solving correct or not, or you can learn a new method of problem solving. You can pause the video right now. I'll be discussing the problem right away. So what is happening? Let's see. To discuss this one, what are the forces will be acting on this particle? Number one is that there are two forces are acting. One is the, suppose v, the velocity of the particle. One force that will be acting is the frictional force, and another force, the magnetic force, too will be acting. And the frictional force is given like this, and magnetic force we know depend upon the speed of the velocity of the particle and also the magnetic field. And we know the force that will be acting is q v cross b. So if I write both the forces that will be acting is equal to F is equal to minus alpha v plus q v cross b. That is the vector sum of both the forces I need to consider. And these are the net force that is acting on the particle. So let's solve this problem. Let's discuss. So take the diagram first. So this is my diagram here. So in this diagram, what we need to do is that suppose at any distance, initial velocity was v0. Initial velocity was v0, but at any instant, suppose the particle is moving with a velocity v at that instantaneous velocity v. So if instantaneous velocity is v there, then to this particle, another force that is opposing this is the friction force, that is equal to alpha v in the opposite direction. And also there is a QVB there, B is coming out of the screen, so there is another force that will be perpendicular to velocity will be acting. This is called the magnetic force, or QV cross B. And in this case, as the velocity is magnetic field into the plane, so I can write the QBB sine 90 degrees. So the magnitude of force will be equal to QB force will be. So how to solve this one? There are two forces we know, but they are in different directions. Their resultant may be like this, somewhere like this. So what is happening? This is providing your tangential acceleration. That force will be light acceleration like this. This will be radial acceleration. Particle will be moving, slowing down, and also will be moving in a curved path. So it will be a circular path as the speed will decreasing. It will radius of curvature will keep on decreasing, and it will move in a logarithmic spiral form, the downward spiral form, and finally come to rest. So to solve this, what we'll do? We'll take a axis like this. Suppose this is my x-axis as is given here, and this will be my y-axis. So this angle is equal to theta. Suppose I take this angle equal to theta. Okay. If I take this angle theta, so this also will be equal to theta. Okay. So now let's resolve, because question is saying to find the coordinate. So x coordinate and y coordinate. So let's resolve x coordinate laxing. So let's everything resolve in terms of x-axis and y-axis. So I will see this will be equal to this b cos theta, and this will be equal to this theta, 90 minus theta. So equal to qvb sin theta will be there. So we write the forces then I can write the x direction, what are the forces that acting, is equal to fx, x direction force, is equal to qvv sine theta minus alpha v cos theta. This is the force in the x directions will be there. And if you see, this theta is unknown quantity, theta is randomly changing, this is continuously changing, so I don't know theta is there. But if I see, I want x and y axis, v cos theta, this angle theta I have taken, so v cos theta is what? X component of velocity, and v sine theta is nothing but the y component velocity. So in this place, if I write like this, in case of v sine theta, I can write vy, and v cos theta, I can write vx, or x component and y component. So you can write like this. And I know this component, this fx equal to max, so acceleration can be calculated like this, divided by m. I can got this. And this is a constant, and q, b, m are constant, alpha m constant. If I not to write this in place of k1, I'll write in this place, I'll write the k2. And if I write k1, k2 I write, then I get this acceleration. But acceleration, x acceleration I got in terms of vy and vx. Because ax was there in function of vx, it was very simple, I could have integrated and got it. But here x acceleration ke sath there y component of v is available. So how to solve this equation, because two things are there. So what to take, that we have to eliminate vy. So let's write the equation the y axis also. Write the y equation, then fy will be equal to qvy cos theta, then will be equal to y direction, will be cos theta, and fy also downward direction, both minus qvy cos theta minus alpha v sine theta will be there. And the way we wrote v cos theta equal to vx, v sine theta equal to vy, that I write, I can write like this, and fy is equal to m ay. So acceleration of ay can be obtained like this, and the way I put the k1 in place of this, k2 in place of this, so I can write in k1, k2, and I get this equation. So now we got two equations. One equation we got this, and another equation we got this. So there are in ax vy term is there along with the x term, and ay vx term is there along the y term. So I need to eliminate this one. So how to do this? Is a coupled equation. So we need to decouple this one. So what to do? This I need to eliminate. So from this, let's calculate vy and substitute here. So vy I can write as vy equal to this. So let's call this equation number 2. Call equation number 2 and take this vy and substitute here. Vy I will take and substitute here. Then I got this. I get this equation as x is equal to k1 into vy. In place of vy I written like this. This one has been written here, and k. So now this I am ay has got. Again vy is eliminated, but ay has come into picture. Let's see what can be done. Do you know anything about the ay or not? That we'll see. So ay we will to find out. So here this is the equation there. So I together ax term has been taken together, and I wrote like this. Simplify these equations. ax, ay, vx. What can be written? We want the y-x coordinate. So bx dx by dt can be written. But similarly, ax is my dx by dt, rate of change of x component velocity, rate of change of y component velocity can be written. So if I write those velocities, then I got this equation. And luckily, this dt will be cancelled. If I cancel this dt, then what I remain with the equation is dvx is equal to minus k1 by k2 dvy. Now I can integrate these equations. Initially the particular origin, so x coordinate was 0. At that time the y component velocity was, because initially it was projected like this, v naught, and there is nothing velocity in x direction, so vy was equal to v naught and vx was equal to 0. Question is asking when the particle will come to rest, means vx equal to 0, vy is equal to 0, what will be the x coordinate? Suppose I give the name x coordinate equal to x naught, then I need to calculate. So if I integrate this one, then dvx integration will be equal to vx, simple integration is there. I put the substitute the limits, and after substituting we get these equations, and if I simplify this, I got the x naught into k1 square plus k2 square is equal to this. Okay, so from this x coordinate can be calculated very easily, and I take this k2, this 2 get cancelled, k2 get cancelled, and I got the x naught is equal to k1 by k2, k1 square plus k2 square into v naught. So K1, K2 value need to be substituted. K1 we know, we have taken K1 in place of QB by M and K2 in terms of alpha by M. So if I put the value of K1 and K2, then we get the equation x0 to be equal to this one. This is my x0 coordinate where the particle will come to. This is a question has been asked that we got the x coordinate where, but suppose nevertheless we can calculate the y coordinate too. So to calculate the y coordinate, what we will do, let's take this equation once again. The equation what we written, we will take this once again. And if we write this equation again, Ax equal to K1 Vy minus K2 Vx, if I write this equation, and in place of Ax is equal to, I write the dVx by dt, Vy is equal to dy by dt, in place of dy by dt, Vx is equal to dx by dt, I write. And I can integrate these equations again, but here dt I can cancel. And now y coordinate I require. So if I integrate this equation, then I got this dt remain. Then I have to integrate this. When x coordinate was 0, y coordinate 0, particular origin, Vy was equal to V0. Sorry, Vx was equal to 0. The x component velocity x was 0. And when the particle will come into x0 and y0, again the x component velocity will be equal to 0. Relation between x and y we can obtain. This is the equation x0 and y0. So after substituting the value, we got the y0 is equal to k2 by k1 x0. We know the value of k2 and k1. So if I put the value of k2 and k1, then I got this equation alpha by kb, and x0 value I substituted what we obtained here. X0 coordinate we calculated, x0 we substitute, this we substitute, we get this equation can be obtained. And if we simplify this one, this qb get cancelled, and we obtain the equations to be equal to y0 is equal to alpha m v0 by q square b square by q square plus alpha square. This we got the x coordinate, we got y coordinate got. So we got that x0 comma y0, the particle will come to rest after moving under the influence of both frictional force and the magnetic force will go, and at a point where it will be coming to rest, that we have calculated by integrating the force, the accelerations of the particle, x acceleration and y acceleration, eliminating, we obtain this one. As it was moving, this was providing the radial acceleration, and as this was providing the tangential acceleration and responsible for change of speed, and this was providing the radial acceleration responsible for change of directions, and it will be eventually be coming to rest at a particular point. And by this time, the whatever work will be done only by the, not by this magnetic force, only by the frictional force work will be done, and the work done by the frictional force will be equal to complete change in the kinetic energy. The what are the m v0 square speed was there, till the time it will not be equal to 0. The friction force will keep on doing work, and after that finally it will come to rest. Hope you have understood the solution, you enjoyed the solutions. Keep watching, I will be coming out in the next video another interesting problem. Till that time, bye, take care.